Hello, good evening, students. Let us try to understand the study of nitric acid, students. Okay, how can you be able to understand the study of nitric acid, student? So, first one, it is if you talk about student, it is a very strong acid. Nitric acid is a strong acid. Okay, so nitrogen form oxo acid such as H2N2O2. Okay, hyponitrous acid, HNO2, nitrous acid, HNO3, nitric acid. Nitrogen also form HNO4, peroxynitric acid. Amongst them, HNO3 is the most important one. So nitric acid is the most important acid, but along with this nitric acid, nitrogen form many type of oxo acid that we have already studied. That is peroxy acid is there, nitrous acid, uh, so nitrous acid is also there, hyponitrous acid is also there. Okay, so next one is there, student. We are going to understand the preparation. Okay, preparation. So if you talk about in the laboratory, nitric acid is prepared by heating KNO3 and NaNO3 and concentrated H2SO4 in a glass resort. Okay. So here if you talk about in a laboratory, nitric acid is prepared by heating KNO3, NaNO3 and concentrated H2SO4 in glass resort. So NaNO3 is there and H2SO4 is there. So NaHSO4 plus HNO3. Okay. So how you are preparing a student, that is nitric acid? You are preparing nitric acid by potassium nitrate or sodium nitrate reaction with sulfuric acid. So sodium hydrogen sulfate and nitric acid you are getting. On large scale, it is prepared mainly by the Ostwald process. This method is based upon the catalytic oxidation of NH3 by atmospheric oxygen. So ammonia reacting with the atmospheric oxygen in the presence of ruthenium catalyst, so it is giving 4NO plus 6H2O. This nitric oxide thus form combined with oxygen to form nitrogen dioxide. This nitrogen dioxide so form dissolve in water to give the nitric acid, student. So nitrogen dioxide is reacting with water to give HNO3 plus NO. NO thus form is recycled and the aqueous HNO3 can be concentrated by distilled up to 68% by mass. Further concentration to 98% can be achieved by dehydration with concentrated H2SO4. Right? They are saying further concentration to 98% can be achieved by dehydration with concentrated H2SO4. Okay. So dear student, what we studied, the most one when you talk about student, that is which we study the laboratory method, student. Okay, laboratory method. So when you talk about the laboratory method, student, it is prepared by sodium or potassium nitrate, KNO3 or NaNO3, student, plus what we are doing, student, H2SO4. So you can write the equation, student. Here is KNO3 plus we are using H2SO4, student. So it will give student KHSO4, student, and plus it will give, that is student, HNO3. So this is what is student nitric acid, right? Next method is there, student, that is known as Ostwald process, student. Ostwald process involve, that is many steps, student. Firstly, what, student, that is ammonia is there, student. What it is doing, it is getting oxidized, student. So it is forming, that is nitric oxide. Okay, plus water molecule, student. This is known as, student, NO. Either you can say nitric oxide, right, student? This NO, student, again getting oxidized, student, in the presence of air, student. Okay, O2, you take 2 mole, so it will give, that is 2NO2, student. Okay, nitrogen dioxide. This 2NO2, student, nitrogen dioxide reacting, getting dissolved in the water, student, and it is giving nitric acid, student, 2HNO3 plus it will give NO. This is what is the Ostwald process, student. Okay, now let us have a look over the next point, student. Properties. If you talk about the properties, student, right? If you talk about the properties, it is colorless liquid, student. Freezing point 231.4 Kelvin and boiling point 355.6 Kelvin. Laboratory grade nitric acid contains 68% of the HNO3 by mass and has a specific gravity of 1.504. In the gaseous state, you know HNO3 exists as a planar molecule with the structure as shown. Okay, in aqueous solution, nitric acid behave as a strong acid, giving hydrogen and nitrate ion. So HNO3 plus H2O, it is giving the hydronium ion plus nitrate ion, right? Concentrated nitric acid is a strong oxidizing agent and attack most metal except noble metals such as gold and platinum. So except gold and platinum, it react with all the metal. The product of the oxidation depend upon the concentration of acid, temperature and the nature of the material undergoing oxidation. If dilute you are taking, student, copper and dilute nitric acid, it will give copper nitrate plus nitric oxide. If you are taking concentrated nitric acid, it will give the copper nitrate plus nitrogen dioxide. Zinc react with dilute nitric acid to give N2O and concentrated to give NO2. Okay. So, dear student, zinc reacting with the 10 mole of HNO3, it is giving ZnNO3 plus 5H2O plus N2O, and zinc with 4HNO3, it is giving ZnNO3. Zinc nitrate is the common, but here the N2O and NO2 is that's different. Now next, student, some metal, okay student, some metals like Fe, Ni, CrAl do not dissolve in concentrated nitric acid because of the formation of passive film oxide on the surface. Concentrated nitric acid also oxidizes non-metal and their corresponds iodine is oxidized to iodic acid, carbon to carbon dioxide, sulfur to sulfuric acid and phosphorus to phosphoric acid. So I2 to HNO3, it is giving HiO3 plus 10NO2, carbon to HNO3, CO2 plus 2H2O, 4NO2, sulfur plus HNO3, it is giving that is NO2. Okay, phosphorus, it will give the phosphoric acid plus NO2. So this is the chemical reaction, student. Next point, brown ring test, student. The most important is brown ring test, student. So the familiar brown ring test for nitrates depend upon the ability of Fe2 plus ion to reduce nitrate to nitric oxide, which react with Fe2 plus to form a brown color complex. The test is usually carried out by adding dilute ferrous sulfate solution to a aqueous solution containing nitrate ion and then carefully adding concentrated sulfuric acid along the side of the test tube. A brown ring at the interface between the solution and sulfuric acid layer indicates the presence of the nitrate ion in the solution. Nitrate ion plus Fe3 2 plus ion, okay, plus 4H plus, it will give the nitric oxide, and this nitric oxide is reacting with the you know this one complex of the iron. It is giving the FeH2O5 type NO. This is the brown color, student, that is specified, that is the presence of Fe2 plus iron. Okay, so this is brown ring test, student. Next one is the uses is there, student, that also you try to learn. The major usage of nitric acid in the manufacture of ammonia, nitrate for fertilizers, and other nitrates for use in the explosive and pyro techniques. It is also used for the preparation of nitroglycerin, trinitrotoluene, and other organic nitro compound. Other major uses are in the picking of stainless steel, catching of metal, and oxidizer in the rocket fuels. Thank you so much for watching, friends.